In this lesson, we're going to talk about domain, range, intercepts, and zeros. By the end of the lesson, you'll be able to investigate and analyze functions and their characteristics graphically, including domain and range, intercepts, and zeros. Let's refresh what a domain is. The domain is the set of all of our x values of a function. We also call this the input, independent variable, and the cause. The range is the set of all y values of a function, also called the output, dependent variable, or the effect. When we look at domain and range on the graph, we look at the set of all x and y values that are contained in our graph. So let's look at some examples. Write the domain and range of each function. Well, let's take a look. First, we got to remember our domain is our x values, and my range is my y values. So for my domain, I'm going to be looking at what values of x are on my graph. Here is my x-axis. So where on my x-axis is my graph? So what we're going to do is draw up here. My graph goes from this point all the way over to this point. Okay. Now which point is this? 1, 2, 3. My graph goes from -3 all the way over to 1, 2, 3, 4. So on the x-axis, my graph goes from -3 to 4. So when I write my domain, we draw our notation, which are these curly brackets. X, we write a bar. As x, we're looking at our domain. Okay. We go from left to right. So we write -3 is less than or equal to x, which is less than or equal to 4. And then we close it with my curly bracket again. So I go from -3 from the left to the right. So all the possible x values on this graph will fall between, all the possible x values will be bigger than -3 but less than 4. They will fall in between this interval. Now we're going to look at our range. Remember that my range is my y. So now I'm looking at where my graph is on my y-axis. So now I'm going to do the same thing, but I'm going to come over here and draw my dot. So here's my highest y, and here is my lowest y. Remember, y is going to be up and down. So what point is this at here? So I go down 1, 2, -2. I go up 1. And just like for domain, we went left to right. We are going to go bottom to top for our range. So again, I'm going to draw my curly brackets, y, such that my lowest number, -2, is less than or equal to, instead of writing x, I'm going to write y, is less than or equal to 1. And I close it out with curly brackets. So there's my domain and my range. Let's look at another example. We're going to look at example D over here. Okay, this one looks a little bit different. In our last example, we had a starting point and an ending point for both my domain and my range. This one's a little bit different. Remember that my domain is my x and my range is my y. Make sure you label that each time you do this until you remember which one is which. So my domain is my x, my range is my y. So for my domain, I again want to look at all the possible x values on this graph. But I have these arrows. These arrows mean that my graph goes on forever in these directions. It doesn't stop. So my domain, I don't have a nice start and stop point. I'm going to have, it's going to go on forever in my x direction. So when that happens, when I have these arrows going on forever in my x direction, I'm going to call that all real numbers, or we can use the symbol. It's an R with two lines. That's our symbol for it. All real numbers. Any number, any x value will work on this graph. In our last one, we had to pick a number between -3 and 4. Now we could pick any number and it would be on this graph. Our range is a little bit different. Again, we look up and down for our range or my y-axis, and I look at my graph. Now it is going up in this direction, but I do have a stopping point here. My graph does end here, and it goes up forever. So in this case, I'm going to do like I did my other example, y and a bracket. But in this case, all of my y values are bigger than where this stopping point is. And the stopping point is at 1, 2, 3, 4, -4. So all of my y's are bigger than -4. So I say y is greater than or equal to -4, and I close my curly bracket. Next, we're going to look at intercepts. We have x-intercepts and y-intercepts. X-intercepts are where the graph crosses or touches the x-axis. Remember, my x-axis is right here. So it's where my graph touches that x-axis right there. The y-intercept is where my graph crosses or touches the y-axis. Notice here how here's my y-axis. My line here is touching the y-axis right there. That's my y-intercept. We have written here how you would write them as points. X, 0 would be your x-intercept. 0, y, whatever your y value is, would be your y-intercept. And we'll talk about that more in class. Let's look at some examples. So we're going to identify the x and y-intercepts of each function. So the x-intercepts, or zeros, remember, is where my graph touches my x-axis. Here's my x-axis, my y-axis. So I'm looking for when does my graph touch this axis. So I'm going to look at all the points where that happens. And I see that I have 3 points. I have one here, and one here. Now remember, for my x-intercepts, I'm going to write them as the points x, 0. So let's look at my first one. This is the point 1, 2, 3, -3, 0, 1, 2, -2, 0, and lastly, I have 0, 0. Those are my 3 x-intercepts for this example. Next, I'm going to look at my y-intercepts. So now I want to look at where does my graph touch my y-axis. And here, it has it in common with the x-intercepts. There's only one. There's only one time where this graph touches the y-axis, and it's right there. It's at the same point of one of my x-intercepts, and that is 0, 0. We will be looking at the other examples on your notes in class. Please come prepared with questions.